We have previously learned that when you have something raised to the 1/2 power, that is the same thing as a square root. For example, 25 to the 1/2 power is the same thing as the square root of 25. So it probably won't come as a surprise to you that the same thing can be done when you have a fraction that's not 1/2. For example, if I had, let's say, 125 to the 1/3 power, well, it doesn't really take a genius to figure out that that is going to be the same thing as a cubed root of 125. Now, cubed root, again, is one that I suggest you have memorized. I suggest you memorize your cubes up to 10 cubed is 1,000. So this is one that you should memorize, but until you have them memorized, you can always go to your calculator, press math, go down to the cubed root function, and put in 125. And there it is. The cubed root of 125 is 5. This is definitely one you should memorize, though. So that's 1/3. 1/3 is the same thing as a cubed root. I'm going to blow your mind here. What do you think it is when you raise it to the 1/4 power? It's the 4th root. So 1,296 to the 1/4 power is the 4th root of 1,296. And I don't expect you to memorize 4th roots or anything higher. So for that, we would definitely use the calculator. So we do math, and then this time we have to come down to the 5th option, that xth root. And we do the 4th root of 1,296, and that comes out to be 6. So 6 to the 4th power is 1296. And so if we have a root that's not a square root, that doesn't mean we can't rewrite the square root or the cubed root or the 4th root as something that has an exponent. We still can. It's just whatever the index is becomes the denominator. So the cubed root is 1/3, 4th root is 1/4. I'll bet you can figure out what the 5th root would be, or the 6th root, or the 7th root, and so on. That's how you write an exponent instead of using a radical. And again, the reason that we would want to do this is because since we know a lot of rules for how to combine or work with terms that have exponents, turning radicals into exponents allows us to do a lot of math work that we wouldn't be able to do if we left them as exponents. So what we're going to do once we finish learning how to do all these conversions from radicals to exponents is we're going to start doing some math with radicals where we can actually combine radicals in the same way that we combine those terms with exponents.